Here we are with the very pinnacle of all the chemical calculations, titrations. This is the most important titration because it's used in analysis and is the backbone of all chemistry work. It's quite straightforward to do, provided you follow very simple rules. Now, in terms of this, the first thing you need to do is from the question to identify the reactants involved, and possibly it may be a product. You work out the number of moles of the reactant using this equation. Moles equals concentration times volume. Then, from the equation, you find the ratio of the reactants or the reactants to the products. And use that ratio then to find the number of moles of reactant or product that you're after. And finally then, you use a moles and volume equation again to find the concentration of the reactant or product. Now, so effectively you are using this equation twice and the ratio from the equation. It's as simple as that. So let's see this in action. So our first example. Here we have sodium hydroxide reacting with hydrochloric acid to form sodium chloride and water. And the question is asking you what volume of 0.2 mole per decimeter cube, that's the concentration, hydrochloric acid, will react with 40 centimeter cube of 0.25 mole per decimeter cube sodium hydroxide. Now, so first thing, this is the most important reactant because we've got the volume and we've got the concentration. This is what we've got to find, hydrochloric acid. So those are the only two things that we are concerned with. So first of all, because we've got volume and concentration, we start with sodium hydroxide. So moles NaOH equals. Now, basically, it's using, as I said, this equation. Moles equals molarity or concentration times volume. So that's what we're using. But what we must remember that the volume must be in decimeter cube. So in this case, sodium hydroxide, the volume is 40 over 1,000 times the concentration, 0.25. So 40 times 0.25 divided by 1,000 will come out as 0.01 mole. Now we need to look at the equation. Now, if we look at the equation, it is obvious that the ratio of sodium hydroxide to hydrochloric acid is 1:1. So effectively that means 1 mole NaOH to 1 mole HCl. Now then, we've worked out we've got 0.01 mole of sodium hydroxide. So must use then 0.01 mole of HCl. And now we're literally there now. So what they want us to find is the volume of HCl. Now, what we do know, we know the number of moles of HCl and we know the concentration of HCl. So using our equation, the volume will equal number of moles divided by concentration. So, very straightforward. Volume HCl will equal number of moles divided by concentration. So the number of moles is 0.01 and the concentration is 0.2. So when we divide that out, 0.01 divided by 0.2, and that will equal 0.05 moles, and it's decimeter cube. Okay, so as you can see, it's fairly straightforward. As I said, we've used this formula twice. We used it at the start to get the number of moles of sodium hydroxide. Then we use the equation to get the ratio. And then we've used it again to get the volume. Okay. Moving on up with a second example. The difference with the second example is that I've used made the equation slightly harder. So what we've got this time, the equation is 2NaOH plus H2SO4 goes to Na2SO4 plus 2H2O. And it says, in the reaction, 40 centimetre cube of sodium hydroxide was neutralised by 25 centimetre cube of a 0.2 mole per decimetre cube sulfuric acid. What is the concentration of the sodium hydroxide? So we know, again, we've got the volume and concentration of sulfuric acid, so we can work out the number of moles. We're given the volume of sodium hydroxide, so we know we've got to work out the concentration. So let's start where we should do with sulfuric acid. So moles, H2SO4. As I said again, we need to use this equation. So moles equals concentration times volume. So concentration 0.2 and the volume is 25 centimetre cubed, so we've got to divide it by 1,000, and that will come out as 0.005 moles. So now we need to look at the equation to get the ratio. So this time, 1 mole H2SO4 goes to 2 mole NaOH. And where I got that from is from the equation. There's our sodium sulfuric acid, nothing in front. And there in front of the sodium hydroxide, we've got 2. So obviously then, let's put our moles. So we've got 0.005 moles of sulfuric acid. So if it's 1:2, that means we can have 0.01 mole NaOH. Now, as they've asked us to find the concentration of sodium hydroxide, remember again, concentration equals moles divided by volume. So concentration NaOH equals the number of moles, which we worked out as 0.01 divided by the volume, which is 40 centimetre cube. Now we've got to divide that by 1,000. So 40 divided by 1,000 comes out as 0.04. So 0.01 divided by 0.04 comes out as 0.25 mole per decimetre cube. So exactly the same method, even though we've got a slight variation in the equation. Doesn't make it any harder, just using the same things again. Now there's a third variant on this, so shall we show you. Now in this one we're asked for something slightly different. The equation is KOH plus HNO3 goes to KNO3 plus H2O. 20 centimetre cube of a 0.125 mole per decimetre cube solution of nitric acid is neutralised. What mass of potassium nitrate is formed? And we're told the relative atomic mass of potassium is 39, of nitrogen is 14, and oxygen is 16. Now, let's look at this. Again, look what we've got. That's our nitric acid. That's our volume, 20 centimetre cube, and its concentration. Now, what are we going to find? This time, we've got to find the mass of potassium nitrate. It's in there. So, we've got a slight variation. But, as always, let's start with what we know. We know the volume and concentration of nitric acid. So if we know the volume and concentration, molarity or concentration and volume, we can work out moles. So that's our first step. So moles HNO3 equals volume 20. Remember, we've got to divide by 1,000 times 0.125, and that will come out as 0.0025 mole. Now, looking at the equation now, we need to look at the ratio. The ratio of potassium hydroxide, of nitric acid to potassium nitrate is 1:1. So 1 mole HNO3 goes to 1 mole KNO3. But as we're using 0.0025 mole of HNO3, then we will form 0.0025 mole of potassium nitrate. Now, the only snag is this time, so we want a mass. So, look at the difference. Two-step calculation. Now, to get the mass, we need the number of moles, which we've got, times the relative formula mass. And that's what we've got to work out for potassium nitrate. Formula mass is the same as 1 mole. So 1 mole KNO3 equals potassium, its relative atomic mass is 39, plus nitrogen, relative atomic mass is 14, plus, as you can see from the formula, there's 3 oxygens. So 39 plus 14, 39 and 14 is 53, plus 48 is 101. Now then, so mass KNO3 equals the number of moles 0.0025 times the mass of 1 mole, and 0.0025 times 101 comes out as 0.2525, which will equal 0.253 grams to 3 significant figures. Now, two-step calculation, but again, we've used the molarity equation, we've used the ratio from the equation, and then we've just used a normal mole equation. Now, that is everything that you can get asked about molarity calculations. So don't be afraid.